We are skipping the pleasantries today and stepping straight into an active crime scene. On trial, a notoriously flawed student answer from the Cambridge IGCSE Physics 0625 paper. You sit down in the exam hall, calculate the numbers, and write down an answer you are absolutely certain is correct, but boom, it's a trap. This explainer puts the evidence front and center because ordinary textbook revision is failing thousands of students who know the math perfectly but completely misunderstand the examiner's mark scheme. Let's get right into it.
So take a look at this completely normal-sounding answer on energy efficiency. Efficiency equals 85, energy lost to heat. A well-prepared student spent 3 minutes calculating this, wrote it down, and moved on with total confidence. The examiner's reality? A massive red 0 marks. Why? Because 85 is just a naked number. Is it a percentage? A decimal? We have no idea. And energy lost to heat? That's conversational English, not Cambridge physics terminology. This entirely plausible-looking sentence literally just cost a student an entire grade boundary.
2. That number represents a really painful truth. Just 2 dropped method marks on energy transfer questions are often the only thing separating an A-star from an A or a passing grade from a total fail. When you're staring down a 40-mark paper, every single line of working out counts. You might think you deeply understand energy stores and work, but in the 0625 syllabus, simply knowing it in your head, that's not enough. You have to prove it using the exact structured language the examiner is legally bound to reward.
Let's lay out the cold, hard evidence. These are the specific, painful learner mistakes that act as common mark-dropping crimes. First up, missing units. If you write a number without joules, watts, or a percentage sign, that mark is dead on arrival. Second, rounding numbers way too early. If you round a multi-step work equation to one significant figure right in the middle of your working out, it exponentially throws off your final answer. Third, vague explanations of energy stores. Writing energy is used up instead of transferred to a thermal store of the surroundings. Examiners are absolutely ruthless about that one. And finally, unjustified graph axis labels. Ordinary textbook revision completely fails to secure marks here because it teaches you the formula, sure, but it doesn't train you to dodge these exact pitfalls.
Now, hold on to this crucial thought. In a moment, I'll show you the exact examiner clue regarding energy conservation that changes your answer completely. But first, you need the framework that makes that clue obvious. We're going to unlock that overarching rule shortly, and it governs every single mechanics question you'll face. But if you don't have the structural foundation built first, you won't even recognize that clue when it's staring you right in the face on exam day.
Section 1. The Bulletproof Answer Framework. How to write like a Cambridge examiner.
Instead of just prosecuting the mistakes, let's build your ultimate defense. This is the exact sequence you must follow for every high-mark calculation or practical response. Step 1. Identify the concept. Before you even touch a calculator, ask yourself, are we talking about work, power, or efficiency? Mentally tag the syllabus area. Step 2. Extract the evidence or data. Pull the exact numerical values from the text and list them out clearly. Step 3. Apply scientific reasoning. This is where your formulas come in. Write the bare formula out explicitly. And step 4, absolutely the most critical one, use examiner wording. This means using correct terminology, substituting values with their proper units, and deploying exam-safe phrasing. This framework is your absolute shield against dropping easy marks.
Section 2, Cross-Examination. You are the examiner.
We are escalating the stakes right now. I'm going to present a classic IGCSE physics scenario, and I want you to actively apply our new framework. Here's the challenge. A motor lifts a 50-Newton load by 2 meters in 5 seconds with an input power of 30 watts. Calculate its efficiency. Think deeply about the hidden relationships we have to untangle here. We have force and distance, which logically gives us the work done. We also have a time factor, which connects that calculated work done directly to useful output power. And finally, we have an input power value, the missing piece we need to ultimately calculate the total efficiency of the motor.
Now carefully consider this student's approach. They wrote, work equals 50 times 2 equals 100. Power equals 100 divided by 5 equals 20. Efficiency equals 20 divided by 30 equals 0.66. I want you to pause this explainer for just a second, predict the exact grade this answer would get out of 4 possible marks, and critically try to spot the fatal errors hidden in plain sight. Go ahead, think about it.
All right, let's pull up the autopsy report and find out exactly where the marks died. The crazy realization here is this. The math on that calculation is technically flawless. 50 times 2 is indeed 100. 100 divided by 5 is definitely 20. The arithmetic checks out perfectly. But the physics communication? It's completely, fundamentally flawed. Let's break down exactly why a senior examiner would aggressively cross this out and deny the student their hard-earned marks.
Let's do a line-by-line breakdown of the destruction. Line 1. Work equals 100. The error? A severely missing unit. The mark scheme reality dictates you must state 100J for joules. In the world of physics, without that J, 100 is totally meaningless. It could mean 100 apples. Line 2. Power equals 20. Again, a missing unit. You absolutely must state 20W for watts. Line 3. Efficiency equals 0.66. The error here is the wrong formatting. Efficiency in Cambridge exams almost universally requires a percentage, so this needs to be translated to 66.7%. Leaving out SI units and presenting naked numbers will absolutely obliterate your score, no matter how good your raw calculator skills are.
Remember that open loop from earlier, the overarching examiner clue? Well, here it is. The principle of conservation of energy. Energy cannot be created or destroyed, only transferred from one store to another. Meaning, total input mathematically must equal total output. This is the absolute bedrock of physics. Recognizing this principle is the ultimate clue to realizing why efficiency can never, ever exceed 100%, or even be fully equal to it in a real-world mechanical system due to thermal energy transfers to the surroundings. Basically, if you run a calculation and get an efficiency of 120%, your framework should immediately flag that you've inverted your input and output numbers.
Let's compare the crime scene directly with the top band correction. We go from our tragic mark-losing string of naked numbers to this top band answer. Work done equals 100 joules. Useful output power equals 20 watts. Efficiency equals 20 watts divided by 30 watts multiplied by 100 equals 66.7%. This proves exactly how step 4 of our framework, using precise examiner wording and relentlessly including those crucial SI units, secures maximum marks. The examiner sees this clear, logical, fully labeled progression and instantly awards full credit. No hesitation.
Section 3. The final verdict. Case closed?
So we've rapidly recapped how to save your calculations from the examiner's red pen. We've proven that mastering energy math is really only half the battle in the 0625 syllabus. The other half is communicating that math with absolute precision. To win the case, every single time, you must state the correct equation clearly. You must substitute data with SI units like joules and watts. You must justify energy transfers with scientific reasoning. But wait, look at that last point. What if the raw data you're meticulously calculating actually comes from a flawed practical experiment? What if the simple pendulum or the balancing ruler experiment you pulled the data from had systemic errors built in? Your perfect, bulletproof math framework will not save you if you cannot critically evaluate the practical data itself.
This is a massive gap that examiners purposefully exploit to drop students' grades from an A-star down to a B. To solve this, you need the top-band evaluation framework for practical data analysis, and learning that skill isn't an option, it's an absolute necessity for full marks. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click the next explainer right now to master the practical data analysis skill and secure those final crucial marks. Do it now, and I'll see you there.